Welcome back to Sleepless Mysteries. Tonight, we lift our eyes to the heavens, where something extraordinary appeared not long ago. On July 1st, 2025, astronomers confirmed the discovery of a new visitor passing through our solar system, a comet they named 3 Atlas. But this was no ordinary comet, it was interstellar, arriving from beyond our sun, traveling across the galaxy before crossing our path. Unlike the countless fragments of ice and rock born here, 3I Atlas came from somewhere else entirely, a messenger from the stars. It is not the first time such a traveler has been seen. Oumuamua in 2017, Borisov in 2019, and now Atlas in 2025, all interstellar wanderers, drifting silently from the deep unknown. Yet, with Atlas, questions grew louder. Its strange trajectory, its brightness, its very presence stirred an ancient memory that perhaps we have seen such visitors before, not in telescopes, but in myths. Not with science, but with stories. For across civilizations, from Babylon to China, from the Mayans to the Greeks, comets were recorded as omens. Fire in the sky, wheels of light, celestial messengers that appeared suddenly and vanished just as quickly. Some were said to bring plague, others victory, and some were described as vehicles of gods or beings from beyond. Were these simply myths born of fear? Or were they, in their own way, records of interstellar visitors like Atlas? These are not tales invented in modern times. They are etched into clay tablets, painted on temple walls, and written in scrolls that still survive. Accounts of blazing lights that cross the heavens, of visitors descending in radiant chariots, of strange objects moving in ways no star or planet should. And now, with Atlas, the echoes grow louder, as if the past and present have folded into one question. Have these visitors returned? You don't need the images to walk this path. You don't need to see the comet glowing against the black sky or the streak of light across the horizon. Just let these words carry you. Close your eyes if you wish. Imagine lying on the ground thousands of years ago, staring upward with no city lights to dim the stars. Suddenly, a new light blazes across the heavens, strange, brilliant, unfamiliar. Imagine the whispers of your people. Is it a god, a curse, or a visitor come again? Before we begin, if you haven't already, subscribe to Sleepless Mysteries so these quiet journeys into the unknown will always be waiting. Tap the like button if these stories bring you calm or wonder. And if you're still awake, share in the comments where in the world you are listening from and what time it is for you right now. Now, let the noise of the present fade. The comet is passing, silent and unbound, a traveler from elsewhere. The stars are watching. And the question remains, did ancient visitors return on the alien comet 3 Atlas? This is Most Unsolved Mysteries. Did ancient visitors return on the alien comet 3I Atlas? And it begins now. Third interstellar object after Oumuamua and Borisov. When astronomers at the Mauna Loa Observatory first noticed the faint streak of light cutting across the night sky in early 2025, they knew immediately that something unusual was unfolding. The object, later named 3 Atlas, carried with it an aura of déjà vu. Humanity had seen this before, but only twice. First with the cigar-shaped wanderer Oumuamua in 2017, and then with the icy comet Borisov in 2019. Both had one thing in common: they were not from here. They were interstellar travelers, messengers from beyond the solar system, and now, with 3I Atlas, the story gained a third chapter. For centuries, comets and asteroids were considered permanent residents of the sun's domain, drifting in long, stable orbits. But Oumuamua shattered that notion. Its strange, elongated shape, rapid acceleration, and lack of a cometary tail left scientists baffled. Just 2 years later, Borisov proved that the first discovery was no fluke, an unmistakable comet, rich in cyanide gas and dust, traveling on a path that would never bring it back. And now, 3 Atlas arrives, not merely as another visitor, but as confirmation that the galaxy is full of such wanderers, worlds, fragments, and relics drifting between stars. The discovery itself was dramatic. The Atlas survey system, designed to detect dangerous asteroids heading toward Earth, flagged the object's orbit as unusual. Its velocity was simply too high. No gravitational interaction within our solar system could have accelerated it to such speeds. It was like watching a car race past you on the highway, then realizing it didn't take the exit at all. It just kept going, heading for another city entirely. This realization transformed 3I Atlas from a statistical curiosity into something far more significant. Astronomers had long theorized that billions of interstellar bodies must exist, ejected from forming planetary systems, tossed into the void by gravitational encounters with giant planets. But seeing them is another matter. They are faint, fast, and fleeting. Catching even one requires both luck and timing. That humanity has now caught 3 in less than a decade suggests one of 2 possibilities. Either our telescopes have only just reached the threshold of sensitivity to detect them, or the galaxy is far more crowded with these silent voyagers than anyone dared imagine. What makes 3I Atlas especially fascinating is how it bridges the legacy of its predecessors. Oumuamua was enigmatic, its behavior so strange that some scientists speculated it might not even be natural. Borisov was the opposite, a classic comet in every sense, its coma and tail proving beyond doubt that it was a natural body. 3I Atlas, however, refuses to fall neatly into either category. It carries echoes of both, a comet-like nature but with features that make it stand apart. To astronomers, it is a reminder that the galaxy is more diverse and unpredictable than textbooks suggest. The fact that we now have a third interstellar object also transforms the science from speculation to comparison. With only one case, everything is an outlier. With 2, we begin to see contrasts. But with 3, a pattern may begin to emerge. By studying 3I Atlas alongside its predecessors, astronomers can ask new questions. Do these bodies share similar compositions, or are they wildly different, reflecting the variety of planetary systems across the galaxy? Do they form in particular ways, or are they merely the random debris of cosmic construction? Each discovery layers new evidence onto a mystery as old as the stars themselves. Yet perhaps the most captivating aspect of 3I Atlas is not its place in a list, but what it represents. Each interstellar visitor is a piece of another world, a fragment of a distant system we may never otherwise touch. They are time capsules carrying the chemistry, the history, and the secrets of their home stars. Every time one enters our skies, it's as though the universe itself has delivered us a gift, a shard of a forgotten story, briefly illuminated before vanishing back into the cosmic dark. Astronomers race to point the world's most powerful instruments at 3I Atlas. Ground-based telescopes tracked its arc across the heavens, while orbiting observatories probed its composition. Time was short. Like Oumuamua and Borisov, it would not linger. Within months, it would fade into the background, too faint to study. But during that window, scientists knew they could unravel details that might redefine our understanding of the galaxy. The discovery also sparked broader reflection. How many of these objects have passed unnoticed, slipping through our skies before technology was ready to catch them? And how many more will come? If 3 have appeared in less than a decade, perhaps the heavens are alive with such travelers. It suggests a universe more dynamic, more interconnected than humanity once believed. The stars do not merely sit in isolation, each system locked away by vast gulfs of emptiness. Instead, fragments wander, cross boundaries, and carry stories from one corner of the galaxy to another. For the public, the arrival of 3I Atlas reignited fascination with the unknown. News outlets drew parallels to Oumuamua's bizarre speculation, whispering of alien probes or lost civilizations. Scientists, careful but excited, emphasized the value of the object as a natural laboratory. Both responses reflect the same truth. Interstellar visitors stir something deep within us. They are reminders of how little we know, how much there is still to discover, and how the boundaries of our world are far more porous than we once thought. The third chapter in this unfolding saga is not just about cataloging another rock in space. It is about acknowledging that the cosmos is alive with movement and exchange. Each interstellar object is not an intruder, but a messenger, carrying with it the fingerprints of alien worlds, the echoes of stellar nurseries, and the possibility of entirely new forms of planetary chemistry. And as 3I Atlas fades into the distance, one thing is certain: it will not be the last. Somewhere, even now, another wanderer is on its way, destined to ignite human curiosity once again as the galaxy slowly opens its doors to us. Hyperbolic orbit. When astronomers plotted the path of 3I Atlas across the night sky, they were struck by its unmistakable trajectory. It wasn't looping in an ellipse like the planets, comets, and asteroids bound to the sun. Instead, its course traced a hyperbola, a mathematical curve that spelled out one undeniable truth: This object came from outside our solar system and would never return. The difference between an elliptical orbit and a hyperbolic one is more than geometry. It is the difference between a resident and a visitor, between belonging and passing through. Every familiar object in our solar system, from the smallest asteroid to the largest planet, follows an ellipse around the sun, forever circling in paths governed by Newton's laws of gravity. But a hyperbola is different. It means the object has too much energy to be captured. It enters, it swings around the sun, and it departs into the infinite dark, destined to travel between the stars for millennia. The mathematics is precise. Astronomers measure something called the eccentricity of an orbit. If the eccentricity is less than 1, the path is elliptical, closed, repeating, eternal. If it equals 1, the orbit is parabolic, barely unbound, an exact balance between capture and escape. But if it exceeds 1, even slightly, the orbit is hyperbolic. For 3I Atlas, the eccentricity was not just above 1, it was well beyond, confirming without doubt that the object had entered our solar system from interstellar space. This was not the first time scientists had traced such a path. In 2017, Oumuamua's orbit revealed the same hyperbolic trajectory. That discovery shocked the world, forcing astronomers to accept that interstellar objects not only exist, but occasionally wander close enough for us to glimpse. Then, in 2019, Comet Borisov reinforced the lesson. Now, with 3I Atlas, the hyperbolic orbit tells the story again. The universe is sending messengers, and we are finally watching closely enough to catch them. But 3I Atlas's orbit is not just proof of origin. It is a narrative in itself. When astronomers traced its path backward, they saw it entering the solar system from the outer darkness, untouched by the planets, heading on a collision course not with Earth, but with proximity to the Sun. As it swung around, its velocity peaked, faster than any spacecraft humanity has ever built, faster than the escape velocity of the Sun itself. When it departed, it carried with it the gravitational slingshot of our star, arcing back toward interstellar space at a speed that ensures no planet, no star, no force in our system could ever reclaim it. To many, this trajectory is a reminder of the vast dynamism of the galaxy. Stars form, planets collide, comets are ejected, and debris scatters like seeds across the cosmic fields. Some of those seeds, after drifting for millions or even billions of years, happen to intersect with the solar system. When they do, their hyperbolic paths betray them as outsiders. They are not ours, yet for a brief moment they pass through our domains, offering us a fleeting chance to study them before they vanish again. The orbit of 3I Atlas also invites speculation about its origin. By tracking its incoming direction, astronomers attempt to trace it back to a potential source star. But the galaxy is not static. Stars move, spiral arms rotate, and gravitational tides reshape the neighborhood. By the time an object like 3I Atlas reaches us, it may have been traveling for so long that its parent system is unrecognizable, far from the path it once held. This makes 3I Atlas a riddle, a messenger without a return address, carrying clues but leaving us to guess at their meaning. The hyperbolic nature of its orbit also sparks a more profound philosophical question. What else drifts between the stars? If rocky fragments, icy comets, and dusty shards wander freely, might larger things exist too? Rogue planets, orphan moons, entire systems adrift. 3I Atlas is small, but its orbit suggests membership in a much larger and hidden population, one that transforms interstellar space from empty void into a highway of unseen travelers. For scientists, the excitement lies not only in the orbital mechanics, but also in the opportunity. A hyperbolic orbit means the object is pristine. Unlike comets that orbit the sun for millennia, gradually shedding material and being reshaped by radiation, an interstellar visitor is relatively untouched. It preserves the chemical and physical fingerprints of the system that birthed it. Every spectrograph aimed at 3I Atlas was a chance to decode those fingerprints, to hold in our hands a sample of another world. The fleeting nature of hyperbolic visitors also creates urgency. Unlike a periodic comet, which can be studied over multiple returns, 3I Atlas would never come back. The weeks and months of its passage were the only opportunity humanity would ever have. This urgency drives collaboration. Observatories worldwide shared data, amateur astronomers contributed observations, and space agencies prioritized telescope time. For a moment, the entire planet looked outward, united by a single celestial traveler. To the public, the term hyperbolic orbit might sound abstract, but its implications are deeply human. It is the difference between permanence and impermanence, between the familiar and the alien. 3 Atlas's orbit symbolizes the fleeting nature of encounters. Here for a moment, gone forever. It is a cosmic reminder of how small we are, how vast the galaxy is, and how much lies beyond the reach of our telescopes. The more astronomers study these hyperbolic visitors, the more they realize their importance. They are not anomalies, but emissaries. Their orbits tell us not just about their speed and direction, but about the processes that launched them. A hyperbolic orbit is evidence of violent beginnings. Perhaps a giant planet hurling a comet outward, perhaps a star's gravitational tides scattering debris. Each trajectory is a map of ancient chaos, preserved in motion. And so 3 Atlas's hyperbolic orbit is not just a line on a graph. It is a story of birth in a distant system, exile into the void, and chance encounter with our own sun. It is proof that the solar system is not isolated but connected, however tenuously, to the rest of the galaxy. And as 3I Atlas vanishes once again into the blackness, its orbit remains etched in human memory, a signature of the wider cosmos, a fleeting brush with the infinite. Would you like me to now continue with odd chemistry, 8:1 CO2 to water ratio in the same style and depth, 1,200 words? Odd chemistry, 8:1 CO2 to water ratio. When astronomers first turned their spectrographs toward 3I Atlas, they expected something familiar. After all, both Oumuamua and Borisov, the 2 previous interstellar visitors, had already given us a baseline. Borisov in particular behaved like a typical comet, spewing cyanide gas and water vapor as it approached the sun. But what scientists discovered in the light of 3I Atlas was something unprecedented. Instead of water being the dominant ingredient, as in nearly every comet we've ever studied, carbon dioxide was present at a staggering ratio of 8:1 compared to water. This finding immediately raised eyebrows in the astronomical community. On Earth, we tend to think of water as the universal solvent of life and the most common ingredient in icy bodies. In our own solar system, comets are water-rich, with carbon dioxide, carbon monoxide, methane, and other volatiles appearing only as secondary components. Even Borisov, though exotic, still showed a water-rich profile that matched expectations. But 3I Atlas upended that assumption entirely. An 8:1 ratio of CO2 to H2O is not just unusual, it is almost unheard of in solar system science. The implications of this chemistry are profound. To understand why, one must consider how comets and icy bodies form. In the early stages of a planetary system, dust and gas clump together beyond the frost line, the distance from the star where temperatures are cold enough for volatile substances to condense. In our system, water freezes readily beyond the orbit of Jupiter, while carbon dioxide and carbon monoxide condense even further out in colder regions. The abundance of water ice in most comets reflects this architecture. Water dominates, with other ices layered in smaller amounts. But 3I Atlas suggests it was born in a very different kind of nursery, one where water was scarce and carbon dioxide reigned supreme. One hypothesis is that 3I Atlas formed in a system around a cooler star, perhaps a red dwarf. Such stars emit less heat, and their frost lines lie much closer to the parent star. In such an environment, the distribution of volatiles could be radically different. Carbon dioxide, which condenses at lower temperatures than water, might have become the dominant ice. If 3I Atlas was ejected from such a system, its composition would carry that unique chemical fingerprint, a fossilized record of its birth conditions. Another possibility is that 3I Atlas originated in a system where water was genuinely scarce. Not every stellar nursery is the same. The interstellar medium varies in composition, depending on local supernova events, stellar winds, and cosmic history. If 3I Atlas formed in a region of space where oxygen was less abundant, water ice may have been rare. In that case, carbon-based ices could dominate. The 8:1 ratio may therefore tell us not just about the object itself, but about an entire planetary system shaped by different cosmic ingredients. The discovery also challenges our assumptions about habitability. In our search for life, we often look for water as the defining marker. The phrase, "follow the water," has guided planetary exploration for decades. Mars, Europa, and Enceladus All are considered prime candidates for life because of their water content. But 3i Atlas reminds us that not all planetary systems prioritize water. If an alien civilization were to follow the water in their own system, they might come up empty-handed, while CO2 or other compounds might play the dominant role in their chemistry of life. Could life exist in a world where carbon dioxide is plentiful and water is rare? The chemistry of 3i Atlas forces us to expand our imagination. Spectrographic analysis also revealed something intriguing. The carbon dioxide did not appear evenly distributed but seemed to erupt in bursts. This suggested that 3i Atlas had layers, with pockets of CO2 trapped beneath a crust, explosively venting as sunlight warmed the surface. The lack of abundant water vapor, however, meant the typical cometary tail was weak or absent. Instead, astronomers described faint outgassing that made the object neither fully comet-like nor asteroid-like. It straddled categories, much as Oumuamua had done, though in a completely different way. This odd chemistry also raises the possibility that interstellar objects may be more diverse than anyone imagined. If 3i Atlas, Borisov, and Oumuamua are the first three interstellar bodies we've ever seen, and all three are wildly different, what does that say about the thousands we have yet to detect? Perhaps each one is a unique product of its home star's chemistry, its birth conditions, and its journey through space. The galaxy may not have a standard comet at all, only a kaleidoscope of frozen relics, each one carrying its own alien signature. Scientists debated whether the 8:1 CO2 ratio could also be the result of processing during the object's long interstellar journey. Cosmic rays, ultraviolet light, and collisions with dust grains can alter the chemistry of icy bodies, breaking water molecules apart and leaving behind carbon-rich residues. Over millions of years, such processing could skew the apparent ratio we observe. If that is the case, 3i Atlas might not have been born with such an extreme imbalance, but could have acquired it as it wandered through the galaxy. Still, even with cosmic weathering, the dominance of carbon dioxide was difficult to explain. What makes this discovery especially significant is how it forces astronomers to reconsider the diversity of planetary formation. Until now, much of our science has been built on the blueprint of our own solar system. We assumed that water would always be common, that comets would always resemble the icy wanderers we see here. But 3i Atlas tells us that our system is just one model among many. There may be planetary nurseries where water is a minor player, and life, if it exists, may be built on entirely different chemistry. The discovery also underscores the importance of rapid response in astronomy. With each interstellar visitor, time is short. By the time 3i Atlas was detected, it was already racing past, with only weeks or months available for observation. In that narrow window, telescopes around the world scrambled to gather as much data as possible. The 8:1 CO2 ratio emerged not from a single observation, but from a global effort, with instruments piecing together spectra across multiple wavelengths. The result is a portrait of alien chemistry that will fuel debates for decades to come. Public fascination was immediate. News outlets seized on the oddity of a comet with almost no water, framing it as a cosmic paradox. To many, it felt like another brush with the unknown, a reminder that the universe still holds surprises. For scientists, the discovery was even more exhilarating because it was not just an anomaly, but a data point. Hard evidence that planetary systems across the galaxy may be far stranger than our imaginations. The chemical puzzle of 3 Atlas is still unresolved. Was it born in a water-poor system? Was it processed by cosmic radiation? Or does it represent an entirely new class of interstellar body, one that we have never seen before? Each explanation carries profound implications for our understanding of cosmic diversity, and as 3i Atlas fades into the dark, it leaves behind a lingering sense of wonder that the chemistry of the universe is not uniform, but endlessly creative. The 8:1 ratio is more than a number. It is a message, a reminder that our assumptions are fragile, that the cosmos refuses to be reduced to simple patterns. Each visitor from interstellar space is not just an object, but a revelation, forcing us to expand our definitions of what is possible. And with 3 Atlas, the lesson is clear. The chemistry of other worlds may be as alien as the worlds themselves, challenging us to rethink the very foundations of planetary science, ancient texts, and the star gods. Throughout the ancient world, civilizations looked to the heavens and found meaning in the lights that flickered against the endless dark. To the Mayans, Sumerians, Egyptians, and Hindus, the sky was not empty. It was alive, filled with gods, messengers, and forces whose power could shape the fate of nations. These cultures, separated by oceans and centuries, shared a curious pattern in their texts. Stories of star gods or heavenly visitors who descended from the skies, imparted wisdom, and promised to return. When modern astronomers speak of interstellar visitors like Three-Eye Atlas, it is tempting to draw lines of connection, how ancient myth and modern science seem to echo one another across time. The Mayans, who charted the movements of planets and comets with astonishing precision, recorded tales of gods who arrived from the stars. The feathered serpent deity Kukulkan, later mirrored in the Aztec Quetzalcoatl, was said to have descended from the heavens, brought civilization to the people, and vowed one day to return. Some Mayan codices even describe fiery signs in the sky accompanying the appearances of such gods. To them, the cosmos was a cycle, and the stars marked the return of powers greater than kings. In Mesopotamia, the Sumerians etched stories of the Anunnaki into their clay tablets. These deities, whose name means those who came from the heavens, were depicted as descending from the sky in fiery craft or riding upon celestial phenomena. Some interpretations, often controversial yet enduring, suggest that these texts speak of actual beings from the stars, visitors who came, ruled, and promised their return. Whether symbolic or literal, the Sumerians left no doubt that they viewed the sky as the domain of beings capable of crossing vast distances to reach Earth. The Egyptians, too, saw the heavens as a realm of gods who could traverse between stars and Earth. The pyramid texts, among the oldest religious writings on record, describe the pharaoh's soul rising into the sky to join the gods in the constellations. Yet, they also speak of beings who descended to guide humanity. The god Osiris was associated with Orion, Isis with Sirius, and their myths were steeped in cycles of death, rebirth, and return. When comets or unusual stars blazed in their skies, Egyptians read them as signs of divine presence, harbingers of return or transformation. Hindu texts, vast and layered with cosmological depth, are perhaps the most explicit. The Vedas and later the Mahabharata describe gods who arrive in vimanas, flying chariots that shine like stars, often described in fiery and mechanical terms. These heavenly vehicles descend, unleash power, and vanish back into the cosmos. The Bhagavad Gita itself presents Krishna not merely as a divine figure, but as a cosmic being, whose form is as vast as the universe, beyond human comprehension. Within Hindu cosmology, time is cyclical, and divine beings repeatedly return at the turning of ages. What is striking across these traditions is the recurring promise that the gods, the star beings, or the heavenly visitors will return. It is not a matter of if, but when. Each culture encoded this expectation into ritual, prophecy, and myth. When a new star or comet appeared in their skies, it was never taken as coincidence. It was a sign, a reminder that the heavens were still watching, and that the visitors had not forgotten their promise. Modern archaeology often interprets these stories as metaphor, allegory, or reflections of natural events. A comet blazing in the sky becomes a chariot of the gods. A solar eclipse becomes a battle among divine beings. Yet the consistency across distant cultures leaves a lingering question. Why did so many civilizations describe their gods not as abstract forces, but as travelers, beings who came from the stars, departed, and vowed to return? The rediscovery of interstellar objects in the modern age reawakens this question. When Oumuamua was first detected, its unusual shape and unexplained acceleration led even Harvard astronomers to consider whether it could be artificial. Borisov, more traditional in its comet-like appearance, nevertheless reinforced the reality of interstellar visitors. Now, with Three-Eye Atlas, the third such body, the idea has taken root. Our skies are not sealed, but permeable. Objects from distant stars arrive, linger briefly, and move on, just as the ancients claimed their visitors once did. Imagine, for a moment, the perspective of the Mayans, the Sumerians, or the Egyptians if they saw three Atlas streaking across the heavens. Would they not have proclaimed that a god had returned, riding a fiery star as their texts foretold? Would they not have looked upon its sudden appearance as proof that the old promises remained alive? What modern science calls a hyperbolic orbit, ancient priests may have called a divine chariot. The language differs, but the awe is the same. For us today, the discovery of Three-Eye Atlas stirs a similar mix of curiosity and unease. Its sudden arrival, its alien chemistry, its fleeting presence, all these qualities echo the myths of heavenly visitors. It is as though the universe itself is writing in the same language the ancients once read. They looked up and saw gods. We look up and see interstellar comets. Yet in both cases, the message is identical. We are not isolated. We are part of a cosmos that sends us visitors, brief reminders that the sky is not silent. In comparing ancient texts with modern discoveries, one can see not contradiction, but continuity. Human beings have always sought meaning in the arrival of celestial strangers. Whether through myth or through science, we recognize that such events are extraordinary. The ancients told of star gods who brought knowledge and departed. Today, astronomers speak of interstellar objects that carry the chemical fingerprints of alien worlds. Both in their own way are gifts from the stars, fleeting but unforgettable. As Three-Eye Atlas fades back into the darkness, it joins not only the legacy of Oumuamua and Borisov, but also the ancient memory of Kukulkan, the Anunnaki, Osiris, and the star gods of the Vedas. It is another reminder that the heavens remain alive, that visitors do come, and that the ancient expectation of return may not have been entirely misplaced. Would you like me to now continue with fiery stars and celestial chariots in the same style and length, 1,100 words? Fiery stars and celestial chariots. For the ancient world, the sky was not merely a backdrop of stars. It was a stage where gods revealed themselves through light, fire, and movement. When comets blazed across the heavens, their luminous tails stretching like banners of flame, people did not see cold ice and dust. They saw omens, divine chariots, and the passage of celestial beings. Many traditions, from Mesopotamia to India, from Mesoamerica to Europe, describe their gods as arriving in fiery stars or comets that served as their chariots, crossing the night sky with purpose and power. These myths, scattered across civilizations, create an enduring tapestry of cosmic symbolism that connects the sudden arrival of an object like Three-Eye Atlas to stories told thousands of years ago. In Mesopotamia, one of the oldest cradles of civilization, celestial phenomena were carefully chronicled on clay tablets. The Sumerians and later the Babylonians linked comets and fiery stars with divine messengers. The Anunnaki, often portrayed as sky beings, were said to descend in blazing craft, sometimes described as stars that moved against the heavens. When an unexpected star appeared, priests would declare it the chariot of a god, sent as a sign of judgment or renewal. To them, the very unpredictability of comets signaled the intrusion of something divine into the ordinary order of the cosmos. In the Hindu tradition, vivid imagery of fiery vehicles appears in the Vedas and the Mahabharata. The gods are said to travel in vimanas, flying chariots that blaze like comets across the sky. These vimanas were not only radiant but often destructive, unleashing beams of fire and energy upon their enemies. Descriptions of these craft often blur the line between myth and something mechanical. Machines of the gods, powered by fire, riding across the firmament. One passage compares the shining Vimana to a bright star in the heavens, trailing fire as it moves. Such imagery resonates with the unmistakable sight of a comet's tail, glowing as sunlight ignites escaping gases. The Egyptians, who read the stars as carefully as they measured the Nile, also saw fiery celestial signs as the movement of divine chariots. The star Sirius, associated with the goddess Isis, heralded the annual flooding of the Nile when it rose in the sky, appearing to blaze with a brilliance unlike other stars. In Egyptian hymns, this brilliance was sometimes described as a shining bark or chariot carrying the goddess back into the world of the living. Similarly, comets or unusual bright stars were woven into their mythology as vehicles of gods, blazing across the heavens before vanishing again into mystery. In Mesoamerican traditions, fire and stars were intimately connected to divine motion. The Mayans saw Kukulkan, the feathered serpent deity, not only as a bringer of wisdom, but also as a being tied to the celestial cycles. Comets to them were not random, they were the fiery trails of gods traversing the night sky. The Aztecs, inheritors of these cosmic traditions, described comets as smoking stars, often linked to Quetzalcoatl's return. These blazing bodies were feared and revered, sometimes interpreted as harbingers of doom, but also as the literal vehicles of divine beings moving between worlds. The Greeks, too, carried this tradition into their epics and myths. Gods like Helios were described as riding fiery chariots across the heavens, dragging the sun itself behind them. While Helios's daily path explained the movement of the sun, other fiery signs, comets, meteors, and unusual stars were sometimes interpreted as the movement of gods or heroes in celestial vehicles. In Homeric hymns, divine presence was often heralded by radiant fire streaking through the night, a motif that echoes the burning spectacle of a comet tearing across the firmament. Even in Norse mythology, fiery stars and comets found symbolic place. The myth of Skull and Hati, wolves that chased the sun and moon, described the heavens as a battlefield where fire and light were hurled across the sky. Meteors and comets could easily be seen as sparks from this cosmic pursuit, streaks of fire drawn by divine hunts. In some sagas, the fiery appearance of stars or celestial omens was tied to the journeys of gods riding radiant steeds or chariots, once again blending natural phenomena with mythic imagination. What unites these traditions is the image of fire, fire as power, fire as divinity, fire as motion across the cosmos. When a comet blazed in the night sky, its sudden appearance, fiery tail, and rapid departure defied ordinary explanation. Ancient people turned to what they knew: chariots, vehicles, and symbols of authority. Just as kings rode in grand chariots across the land, so too did gods ride in fiery ones across the heavens. The association was inevitable. This lens casts new light on the modern discovery of Three-Eye Atlas. When astronomers announced its sudden arrival following a hyperbolic path that proved it came from beyond our solar system, one could imagine how the ancients might have reacted. To them, it would not have been a scientific oddity, but a direct manifestation of divine promise, a god returning in a fiery chariot. Its chemistry, strange and alien, would have been secondary to its spectacle. The mere fact that it appeared suddenly, blazed in the sky, and then vanished forever would have been interpreted as proof of the myths. The chariot had come, delivered its message, and returned to the heavens. The comparison is not as far-fetched as it seems. Even in our modern era, comets and interstellar objects stir deep emotions. When Oumuamua raced past, scientists debated whether its shape and acceleration might even hint at something artificial, a probe rather than a natural body. In 2019, Borisov drew awe as the first unmistakable comet from another star. And now, with Three-Eye Atlas, we are reminded that the galaxy is alive with such visitors. We may no longer call them chariots of the gods, but the awe they inspire is much the same as it was for the Mayan priest, the Egyptian scribe, or the Vedic poet. Moreover, fiery chariots were never only about transportation in myth, they were about power and transformation. Gods who rode such vehicles brought change, whether destruction, renewal, or wisdom. In the same way, interstellar objects bring transformation to our understanding of the universe. Three-Eye Atlas, with its odd chemistry and unbound trajectory, forces us to rethink planetary formation, cosmic chemistry, and the diversity of other worlds. Its fiery presence in our skies does not only remind us of myth, but actively changes our scientific worldview. There is also a symbolic resonance between the unpredictability of comets and the sudden interventions of gods. In myth, divine chariots never appeared on schedule. They broke into the ordinary flow of time, disrupted human lives, and then vanished. Comets, too, are unpredictable. Their sudden blaze across the night sky reminds us of forces beyond our control. Ancient cultures encoded this sense of disruption into prophecy. Modern astronomers encode it into orbital mechanics. But the effect, the awe and recognition of something greater than ourselves, remains constant. The enduring image of fiery stars as divine chariots also speaks to humanity's need to connect the earthly with the cosmic. A chariot is a human invention, a vehicle of kings and warriors. By imagining gods riding fiery chariots across the heavens, ancient people projected their own experience onto the cosmos, making the vastness of the universe relatable. Today, we do something similar when we speak of spacecraft, probes, and missions to the stars. Our modern chariots are built of metal and fueled by chemistry, but they serve the same symbolic function, linking humanity to the heavens. Three-Eye Atlas, then, is more than an interstellar visitor. It is a reminder of this continuity. Its fiery presence in the sky bridges myth and science, echoing the ancient imagery of divine chariots, while fueling modern discoveries about alien chemistry and cosmic dynamics. When we look at it, we do not only see data, we see the same fiery spectacle that once inspired myths of gods riding across the heavens. And as it departs, we are left with the same mixture of awe and longing. The ancients wondered when the gods would return in their fiery chariots. We wonder when the next interstellar visitor will blaze across our skies. The language has changed, but the expectation endures. Would you like me to continue with the final theme, comparing Three-Eye Atlas's arrival to those myths in the same 1,200-word documentary style? Comparing Three-Eye Atlas's sudden arrival to those myths. When astronomers first announced the discovery of Three-Eye Atlas, it felt like a familiar story. A faint light, unexpected and unexplained, appeared in the night sky. It did not belong to any cataloged comet or asteroid. Its orbit was too strange, its speed too great, its presence too fleeting. For scientists, it was proof of a third interstellar visitor, following in the footsteps of Oumuamua and Borisov. For those who study myth and history, however, its sudden arrival seemed to echo tales told for thousands of years. Stories of gods, fiery stars, and heavenly messengers who promised to return. The comparison between Three-Eye Atlas and those ancient myths is not a matter of believing one over the other, but of recognizing the continuity of awe, how humanity has always looked to the sky and seen something more than just rocks and ice. The first parallel lies in the suddenness of the event. Ancient texts often describe the appearance of divine chariots or heavenly visitors as abrupt and transformative. A fiery star would blaze into the sky without warning, disrupting the familiar constellations. To the ancients, this was a sign that the gods were intervening, delivering a message or heralding a great change. In the same way, Three-Eye Atlas appeared without prediction. It was not part of any known cycle. Unlike Halley's Comet, which returns on a clockwork schedule, interstellar visitors appear suddenly and vanish forever. That very unpredictability was what made comets sacred to ancient peoples, and it is what makes Three-Eye Atlas scientifically priceless. The second parallel is motion across boundaries. Ancient myths often describe gods descending from the heavens in blazing vehicles, crossing from their realm into ours. These were not stationary stars. They were moving, alive with purpose. Three-Eye Atlas mirrors this imagery through its hyperbolic orbit. It is not bound to the sun. It entered our solar system, swung close, and departed, never to return. In mythic terms, this is the behavior of a messenger who comes, speaks, and leaves. The orbit becomes a story: arrival, passage, departure. Just like the cycles of divine visitation described in texts from the Vedas to the pyramid inscriptions. Another layer of similarity emerges in the physical appearance. To the naked eye, a comet is not merely a dot of light, but a spectacle, a blazing head with a long, luminous tail. In antiquity, this fiery display was likened to a chariot pulled by horses, a serpent of light, or a torch carried by a god. When Three-Eye Atlas released its strange gases, creating faint emissions dominated by carbon dioxide, it too formed a hazy, glowing presence. Imagine the ancient Egyptians or the Mayans seeing such a spectacle. They would have recognized it instantly as a celestial chariot, the very image described in their sacred texts. The chemistry of Three-Eyed Atlas adds yet another mythic resonance. An 8:1 ratio of carbon dioxide to water is virtually unknown in solar system comets. This alien signature is unlike anything we are accustomed to. Myths, too, emphasize the otherness of heavenly visitors. The gods are never exactly like humans. Their vehicles, their weapons, their very essence are strange and unfamiliar. In Hindu descriptions, Vimanas emitted sounds and lights no human machine could replicate. In Sumerian lore, the Anunnaki's fiery descent left trails unlike natural phenomena. Three Atlas's odd chemistry serves as a scientific reflection of this strangeness. It is not of this world, and its very makeup sets it apart, an alien traveler in every sense. Cultural response also provides an important comparison. For ancient peoples, the sudden arrival of a comet could inspire both fear and reverence. It was seen as an omen of change, sometimes the death of a king, sometimes the rise of a new dynasty, sometimes the promise of divine return. In our modern age, though we no longer interpret comets as omens of royal fates, the response is still powerful. News of Three Atlas spread quickly, captivating headlines around the world. Social media echoed with speculation, excitement, and even conspiracy theories. Scientists rushed to gather data. The sense of urgency of witnessing something rare and meaningful was no different from the awe that gripped ancient priests standing beneath a blazing sky. Another striking comparison is impermanence. Myths consistently describe heavenly chariots as transient. They do not linger. They arrive, blaze brilliantly, and vanish, leaving behind only memory and prophecy. Comets behave in exactly this way. 3I Atlas appeared, gave us a short window for observation, and disappeared into interstellar space. We will never see it again. That fleeting quality is central to its meaning. For ancient peoples, it signaled that the divine was beyond control. For scientists today, it reminds us of the limits of observation and the importance of seizing opportunities quickly. In both interpretations, the fleeting nature of the visitor heightens its significance. There is also the matter of return. Ancient myths often emphasize that the gods will come back. Kukulkan promised to return to the Mayans, Quetzalcoatl to the Aztecs, Osiris to the Egyptians, Vishnu and his avatars to the Hindus. Each tradition held a vision of cyclical visitation, where the heavens would once again open and deliver a divine presence. Interstellar objects mirror this promise in a paradoxical way. While each individual object like 3I Atlas never returns, others will. Oumuamua, Borisov, and now Atlas, all within less than a decade, show us that the cycle is real, if not tied to a single body. The galaxy will continue to send us visitors, unpredictable and rare, fulfilling in a scientific sense what the ancients expected in a mythic one, the return of star travelers. Comparisons also extend to the idea of messages. In myth, a fiery chariot is never silent. It comes to signal something, a shift in destiny, a call to action, a reminder of divine power. In science, interstellar objects are also messengers. They carry the chemical signatures of their birth systems, clues about planetary formation in distant stars, and data that reshape our understanding of the galaxy. 3I Atlas, with its bizarre chemistry and alien orbit, tells us a story not through prophecy, but through science. Yet both are messages, both invite us to rethink our place in the cosmos. It is easy to dismiss these comparisons as romantic or symbolic, but perhaps they reveal something deeper. A human constant. Across time, people have always sought meaning in the heavens. Ancient myths and modern astronomy are not opposites, but different languages describing the same experience, the awe of encountering the unknown. The Mayan priest saw a god's fiery chariot. The astronomer sees an interstellar object. Both gaze upward, both recognize the rarity of the event, and both feel the stirring of questions larger than themselves. Finally, there is the question of continuity across eras. For the ancients, fiery stars connected heaven and earth, reminding them of a larger cosmic order. For us, interstellar objects connect our solar system to the galaxy, reminding us that we are part of a greater whole. In both cases, the visitor is a bridge between worlds, between times, between myth and science. 3I Atlas's sudden arrival is not merely a scientific data point, it is a continuation of humanity's oldest story. That the sky is alive, and that from time to time, travelers from beyond arrive to remind us of our place in the cosmos. The ancients called them gods. We call them interstellar objects. But the wonder is the same. 3 Atlas blazed briefly across our sky, then vanished, leaving us with more questions than answers, just as the myth said the heavenly chariots always would. In that sense, science and myth converge. Both recognize that the universe is not silent, and that every sudden star in the heavens carries a story, whether written in prophecy or in spectra. Would you like me to now expand this series further, perhaps tying 3 Atlas into modern cultural myths, alien visitors, probes, cosmic omens, in the same narrative style? Oumuamua and the alien probe theory. In October of 2017, astronomers using the Pan-STARRS telescope in Hawaii spotted a faint, fast-moving object hurtling through the solar system. At first, it was cataloged like countless others, assumed to be a comet or asteroid from our own celestial neighborhood, but almost immediately it began to defy expectations. Its orbit was hyperbolic, meaning it was not bound to the sun and had entered from interstellar space. That made it the first confirmed interstellar object ever detected, a cosmic stranger passing through our system. Yet what truly unsettled scientists was not its orbit, but its behavior. Oumuamua, as it was named, a Hawaiian word meaning scout or messenger from afar, seemed to accelerate unnaturally as it left the solar system. After swinging around the sun, it sped up, gaining velocity without any clear explanation. Normally, comets gain acceleration by venting water vapor and other gases, producing jets that push them along, but no such jets were detected from Oumuamua. It had no visible coma, no tail, no obvious outgassing. Yet it was moving faster than gravity alone could explain. This anomaly captured global attention. Scientists scrambled to explain it, proposing that invisible outgassing too faint to detect might have provided the push. Others speculated it could have been propelled by radiation pressure if its shape was extremely thin, like a sheet or sail. That idea, in particular, led to one of the most controversial theories in modern astronomy, Avi Loeb's hypothesis that Oumuamua might not be a natural object at all, but a probe, an artifact of alien technology. Loeb, a Harvard astrophysicist, pointed out that Oumuamua's elongated, pancake-like shape and unexplained acceleration fit the behavior of a light sail, a thin sheet designed to harness the push of starlight. If an advanced civilization had built such a device, it could traverse interstellar space without fuel, propelled solely by radiation. To Loeb, the simplest explanation for Oumuamua's strange behavior was also the boldest, that it was artificial. The scientific community reacted with a mix of fascination and skepticism. Many dismissed the alien probe idea as speculative, arguing that extraordinary claims require extraordinary evidence. Alternative explanations were offered. Perhaps it was composed of exotic hydrogen ice, evaporating invisibly. Perhaps it was a shard from a disrupted planet with unusual reflective properties. Yet none of these theories fully satisfied the data. The mystery remained. Why did this object, alone among the thousands we've observed, accelerate in such a peculiar way? Public imagination, however, was captivated. Media headlines splashed with the possibility of the first confirmed alien artifact. Even as mainstream astronomers urged caution, the notion that Oumuamua might be more than just rock or ice struck a chord. Science fiction had suddenly edged closer to science fact, and the world was reminded that the universe might still hold surprises beyond our comprehension. Beyond its acceleration, Oumuamua's very shape deepened the intrigue. Initial measurements suggested it was at least 10 times longer than it was wide, an extreme aspect ratio unlike any known asteroid or comet. Later refinements hinted it might be more pancake-like, wide and flat. In either case, its form was extraordinary. Natural processes typically produce more rounded or irregular shapes, not extreme geometries. Combined with its reflective surface, this strange structure further fueled speculation. Could it be a fragment of a shattered world, sculpted by cosmic forces? Or was it engineered, designed with intent? The alien probe theory, though controversial, forced astronomy to confront an uncomfortable truth. We had entered a new era of discovery. For the first time, humanity had seen something from beyond our solar system, and it did not fit neatly into known categories. Whether natural or artificial, like Oumuamua represented the vast unknown that lies between the stars. In the years that followed, the debate never fully settled. Loeb doubled down on his claims, publishing books and articles arguing that scientists should not dismiss the possibility of extraterrestrial technology. Critics countered with new models, suggesting that natural explanations, like nitrogen ice fragments or complex rotational dynamics, could account for the data. Yet none of these fully erase the lingering strangeness. To this day, Oumuamua remains one of the most enigmatic objects ever observed, its true nature still uncertain as it drifts into the void beyond our reach. The significance of Oumuamua lies not only in its mysteries, but in its timing. Its discovery came just as humanity was expanding its ability to detect and track near-Earth objects. It served as a wake-up call, the proof that interstellar visitors are not hypothetical but real, and that our instruments are finally sensitive enough to detect them. That it also carried such peculiar traits only heightened the sense that the cosmos had more in store for us. Perhaps the greatest legacy of Oumuamua is the way it reshaped our questions. Before 2017, the idea of alien artifacts drifting between stars was the stuff of imagination. After Oumuamua, it became a legitimate topic of debate in scientific journals. Whether or not it was truly a probe, it forced us to confront the possibility that evidence of other civilizations might not come in the form of radio signals or distant planets, but as silent passing visitors, fragments or devices that wander into our skies. In that sense, Oumuamua was indeed a scout, as its name suggests. It was a messenger, not just from interstellar space, but from the future of astronomy itself. It told us that we must be ready, that the universe will continue to send us enigmas, and that some of them may challenge our very assumptions about what is natural, what is artificial, and what it means to be alone in the cosmos. Would you like me to now continue with Three Eye Atlas's exotic chemistry and odd trajectory in the same 1100-word style? Three Eye Atlas's exotic chemistry and odd trajectory. When astronomers identified Three Eye Atlas in early 2025, the excitement was immediate. It was only the third confirmed interstellar object in history, following Oumuamua in 2017 and Borisov in 2019. By itself, that would have been enough to guarantee attention. But very quickly, scientists realized that Three Eye Atlas was more than just another entry in the growing catalog of interstellar visitors. Its trajectory and its chemistry both revealed anomalies that placed it in the same mysterious category as Oumuamua: enigmatic, puzzling, and perhaps even unsettling. The first clue came from its trajectory. Like its predecessors, Three Eye Atlas was traveling on a hyperbolic orbit. This meant it was not bound to the sun, but only passing through, destined to return to the interstellar void. That was expected. What was not expected, however, was how peculiar the orbit seemed when measured against models of typical interstellar debris. Its approach angle was steep, cutting into the solar system in a way that gave astronomers only a narrow window of time to observe it. Its velocity, too, was unusual. Not quite as extreme as Oumuamua's, but still faster than most gravitational models predicted. Some astronomers noted that the path suggested an origin not from the galactic plane where most stars and debris lie, but from a more eccentric trajectory, as though it had been launched or disturbed by forces not yet understood. Even more intriguing was the possibility of non-gravitational acceleration. Careful tracking of its motion suggested tiny deviations from the path predicted purely by Newtonian physics. This echoed the mystery of Oumuamua, which had accelerated unexpectedly as it departed. In that case, the explanation might have been outgassing, a cometary release of gases giving a slight push. But Oumuamua showed no visible tail, leaving the mystery unresolved. With Three Eye Atlas, the situation was similarly ambiguous. Small shifts in its velocity forces beyond gravity, yet its visible behavior didn't align neatly with ordinary cometary outbursts. The trajectory, therefore, became not just a curve on a chart, but a question mark pointing toward the unknown. If its orbit raised eyebrows, its chemistry sent shockwaves. Spectroscopic analysis revealed that Three Eye Atlas had an extraordinarily high carbon dioxide content compared to water. In fact, the ratio was about 8:1, 8 parts CO2 to 1 part H2O. For context, comets within our solar system are overwhelmingly dominated by water ice, with carbon dioxide and carbon monoxide appearing only as minor constituents. Even Borisov, which was clearly a comet, had a composition more or less consistent with solar system norms. But Three Eye Atlas was something else entirely, a body in which carbon dioxide vastly outnumbered water. This was unprecedented. Such a skewed ratio had never been seen before, raising profound questions about the conditions in which Three Eye Atlas had formed. Did it originate in a system where water was rare, perhaps because of lower oxygen abundance in its parent star's nebula? Was it formed around a cooler star where carbon dioxide could freeze closer to the star while water was scarce? Or had it undergone strange chemical processing during its journey through the interstellar medium, bombarded by cosmic rays and ultraviolet light that destroyed water while leaving carbon dioxide intact? Each hypothesis opened new doors into cosmic chemistry, and none provided a complete answer. For some scientists, the strangeness of its chemistry fed into the same kind of speculation that had surrounded Oumuamua. If an object behaved in ways unlike anything we've seen, could it possibly be more than natural? Was it conceivable that Three Atlas was artificial, or at least altered by processes not yet understood? The alien probe theory, while still controversial, resurfaced in discussions. After all, when 2 of the 3 interstellar visitors detected so far show anomalies, Oumuamua with its unexplained acceleration, Three Eye Atlas with its bizarre composition and odd path, it becomes harder to dismiss the coincidences as trivial. Others pushed back, arguing for natural explanations. They suggested that Three Eye Atlas could be a fragment of a larger body, its composition reflecting unusual geological processes on a distant world. Perhaps it was once buried deep inside a planetesimal, where water was depleted but carbon dioxide remained locked in. Or perhaps it had formed in an unusually carbon-rich disk, evidence that planetary systems elsewhere follow very different rules than our own. Whatever the explanation, the implications are immense. If 3 Atlas is natural, it demonstrates that planetary systems can produce comets with compositions radically unlike anything we see here. That expands our picture of cosmic diversity, showing that the galaxy is filled with chemical environments far stranger than our solar system suggests. If it is artificial, or at least influenced by some process beyond the natural, then it would represent one of the most important discoveries in human history. Its chemistry also has implications for the search for life. Astrobiology has long been guided by the mantra, "Follow the water," since life as we know it depends on water as a solvent. But what if water is not universal? What if some planetary systems favor other compounds like carbon dioxide or methane as the dominant volatiles? Could life exist in such environments, building its chemistry on different foundations? 3I Atlas, with its strange imbalance, forces us to widen our imagination. Perhaps alien biospheres, if they exist, may be nothing like Earth's, and interstellar comets like this one are the first hints of that reality. The timing of the discovery adds to the resonance. It came less than a decade after Oumuamua, reinforcing the idea that interstellar visitors are not once-in-a-lifetime rarities, but relatively common. The fact that 2 of the 3 detected so far have defied expectations only amplifies their mystery. Some astronomers have begun to argue that interstellar objects might be the most important frontier in planetary science. By studying them, we can sample material from across the galaxy without leaving our solar system. Each one is a messenger, carrying the signature of a world we may never otherwise reach. Public reaction to 3I Atlas reflected this sense of wonder. News outlets emphasized its alien chemistry, describing it as a comet unlike any other. Online discussions linked it immediately to Oumuamua, drawing parallels and reviving debates about alien probes, interstellar artifacts, and the possibility of intelligent life. Even skeptics acknowledged that the discovery demanded serious study. The universe, once again, had delivered something we could neither fully explain nor easily dismiss. As it faded from view, scientists scrambled to gather as much data as possible. The challenge with interstellar objects is always the same. Their visits are brief, their windows of observation narrow. By the time instruments are fully mobilized, the object is already receding into darkness. With 3I Atlas, researchers captured enough spectra and photometry to confirm its anomalies, but much remains unresolved. Like Oumuamua before it, it has left us with more questions than answers. In the end, the story of 3I Atlas is not only about an odd chemistry or a peculiar trajectory, it is about what such anomalies mean. They remind us that the universe is not uniform, that the rules we infer from our own solar system are just one example among countless possibilities. They also remind us of the limits of certainty. Sometimes the cosmos presents us with puzzles that resist easy solutions, forcing us to live with mystery. And perhaps that is the greatest lesson of all, that discovery is not about finding final answers, but about opening doors to new questions. Like Oumuamua, 3I Atlas has joined the pantheon of enigmas that challenge our understanding. Its exotic chemistry, its odd path, its fleeting presence all point toward a universe far stranger than we imagine. Whether natural or artificial, whether messenger or mere wanderer, it has already served its purpose, to remind us that we are not the center of the cosmos, but participants in a vast, interconnected galaxy where surprises still streak across the sky without warning. Would you like me to now create the next documentary arc connecting Oumuamua, Borisov, and 3I Atlas together as a trilogy of interstellar mysteries in the same 1,200-word style? Could these interstellar objects be technologies disguised as comets? When astronomers first tracked Oumuamua across the night sky in 2017, the idea that it might be and not be a natural object seemed almost too bold to voice. And yet its unexplained acceleration and strange shape led some to wonder whether we were seeing not a rock or a comet, but something altogether different. Could it be that interstellar objects like Oumuamua and later Three Eye Atlas, are in fact technologies, artifacts from alien civilizations, cleverly disguised as comets or debris drifting between the stars, the thought is as unsettling as it is fascinating. For centuries, humanity has assumed that comets and asteroids are simply the rubble of planetary formation, icy and rocky leftovers circling the sun, occasionally falling inward where we can see them. The first interstellar visitors seem to fit this narrative at first glance. Borisov in 2019 was a textbook comet, trailing cyanide gas and dust like the ones we know so well. But Oumuamua and Three Eye Atlas broke that pattern. One accelerated without a tail, the other showed chemistry so bizarre it defied every known solar system model. Each carried anomalies that resisted neat explanation. The alien probe hypothesis takes these anomalies at face value. It asks, if something moves like technology, could it be technology? If a device were designed to cross the galaxy, it would need to be robust, able to survive millions of years adrift, and perhaps even disguised to avoid detection. What better camouflage than to appear as a comet? After all, comets are plentiful, their shapes irregular, their paths eccentric. A probe cloaked in cometary disguise could slip across systems unnoticed, its presence attributed to natural causes, until, perhaps, it did something unusual, like accelerate in defiance of gravity or reveal a chemistry unlike anything we expect. In this light, Oumuamua's acceleration is not a mystery but a clue. It behaved as though it were equipped with a sail, catching the faint push of sunlight, just as some human engineers now dream of propelling spacecraft with solar sails. Its elongated or flattened shape, reflecting light in strange ways, seemed consistent with such a design. If we, with our limited technology, have already conceived of light sails and probes designed to traverse interstellar distances, could a far older and more advanced civilization have built them long ago? And what of Three Eye Atlas? Its alien chemistry could, in this speculative view, be evidence not of natural diversity, but of design. A machine, after all, would not need to mimic the chemistry of water-rich comets. It could be built from carbon-heavy compounds, optimized for strength or durability in ways we don't yet understand. Its odd trajectory, perhaps slightly off from gravitational predictions, could likewise hint at subtle control, a course correction, or the faint push of a technology hidden within. The probe hypothesis does not suggest that these objects are active scouts hovering over Earth, beaming signals, or watching us. Instead, it entertains the possibility that they could be derelicts, ancient technologies launched long before our species even existed, still wandering the galaxy. They might be broken, their missions long ended, their builders extinct, or they might be passive messengers designed to drift until discovered, their mere existence meant to prove a point, that we are not alone. Skeptics are quick to point out the dangers of such thinking. Extraordinary claims require extraordinary evidence, and so far neither Oumuamua nor Three Atlas has provided proof of anything artificial. No signals were detected, no metal reflections, no geometric designs visible. But the probe hypothesis challenges us to consider whether we would even recognize alien technology if it passed us by. If a civilization were millions of years ahead of us, its artifacts might look nothing like the machinery we imagine. They might resemble natural objects because they were designed to, or because their technology is so advanced it blurs the line between machine and nature. For ordinary people, the allure of the idea is undeniable. The universe is vast, and the odds that we are the only intelligence within it grow smaller with every discovery of new exoplanets and habitable zones. To think that objects from another system might already have entered ours, silent, unannounced, and enigmatic, feels like the ultimate confirmation of our suspicions. We may not have seen their builders, but perhaps we have seen their tools. In this sense, the alien probe hypothesis is not just science fiction. It is a test of imagination and humility. It forces us to ask whether our assumptions about what is natural might blind us to evidence that is right in front of us. If a stone fell from the sky in ancient times, people saw it as divine. Today, when a strange object passes through the solar system, we see it as a comet. But what if both interpretations miss the mark? And the truth is something in between, something extraordinary hiding in the ordinary. The possibility that interstellar objects are technologies disguised as comets remains speculative, but speculation has value. It pushes us to look harder, to design better instruments, and to prepare for the next time the universe sends us a visitor. Because if even one of these bodies turns out to be more than ice and rock, the implications would be staggering. It would mean we are not alone. It would mean the galaxy is seeded not just with planets and stars, but with the fingerprints of intelligence scattered across the void like cosmic breadcrumbs. 3i Atlas may not provide the final answer, neither did Oumuamua, but each object adds to a growing sense of mystery, a sense that we are on the edge of discoveries that could change everything. Whether probe or comet, artifact or accident, they remind us that the universe is not empty. It is alive with travelers, some of which may carry secrets we have only just begun to imagine. Would you like me to continue with Avi Loeb's theories and why many scientists resist in the same 1,100-word style? Explore Avi Loeb's theories. When Oumuamua passed through the solar system in 2017, most astronomers classified it as a comet or asteroid, albeit an unusually shaped one. Yet it behaved in ways no comet or asteroid ever had before. It accelerated slightly as it departed the sun's gravity, despite showing no visible tail or jets of water vapor. It reflected light oddly, as though its shape were elongated or even pancake-like. It tumbled in a peculiar way, and its brightness shifted in ways that did not quite match ordinary space rocks. These mysteries left the door open for bold speculation, and no one stepped through that door more firmly than Avi Loeb. Loeb, a Harvard astrophysicist and longtime thinker about cosmic frontiers, put forward the idea that Oumuamua might not be natural at all. Instead, he suggested it could be an artifact of alien technology, a light sail, designed to travel between stars. To many, this sounded like science fiction intruding into astronomy, but Loeb framed it differently. His point was not that we had proof of aliens, but that the anomalies of Oumuamua were better explained by an artificial hypothesis than by strained natural explanations. A light sail, as Loeb explained, is a simple but powerful idea. Imagine a thin sheet, no thicker than a razor blade, stretched across tens or even hundreds of meters. Sunlight itself exerts pressure, however faint, on any surface it strikes. For a sail so light and thin that pressure could provide propulsion across vast distances, requiring no fuel, only patience. Humans have already tested prototypes of such technology, like the Japanese Icaros mission and the Planetary Society's light sail projects. If we, with our young civilization, can imagine such a technology, why couldn't another, older civilization have built one long ago? Loeb argued that Oumuamua's acceleration fit this model. It acted as though it were being pushed by sunlight, not by cometary jets. Its strange dimensions, inferred from the way it reflected light, also seemed consistent with a flat, sail-like structure. To Loeb, this was not only possible, but plausible. It was, he insisted, the simplest explanation given the data. This theory sparked controversy across the scientific world. Many astronomers resisted, pointing out that extraordinary claims require extraordinary evidence. They argued that natural explanations, though imperfect, were still more likely. Some suggested Oumuamua was a chunk of hydrogen ice evaporating invisibly and providing thrust. Others thought it might be a fragment of nitrogen ice, chipped from the surface of a Pluto-like exoplanet. Still others speculated it could be a shard of rock with exotic reflective properties. Yet each of these theories came with problems. Hydrogen and nitrogen ice are unstable over interstellar journeys, making it unlikely they would survive, and the reflective models often required conditions so unusual they stretched credibility. Loeb responded by emphasizing the scientific method. To him, the role of science is not to dismiss bold ideas, but to follow the evidence wherever it leads. If all natural explanations struggle, then why not consider the artificial? He accused the scientific community of clinging to conservative assumptions, unwilling to face the possibility that alien technology might be staring us in the face. If it looks like a duck and quacks like a duck, he wrote, why assume it's something else entirely? In 2021, Loeb published a book titled Extraterrestrial: The First Sign of Intelligent Life Beyond Earth. In it, he laid out his argument not just about Oumuamua, but about the broader state of science. He claimed that astronomy was too often governed by groupthink, with researchers avoiding controversial ideas for fear of ridicule. He argued that humanity should be open to the possibility that alien civilizations exist, and that we may encounter their technologies not through dramatic signals, but through subtle artifacts drifting between the stars. Loeb also tied his theories to larger projects, like the Galileo Project, which he launched with colleagues to search systematically for evidence of extraterrestrial technology. Rather than waiting passively for signals from space, the project aims to scan the skies with telescopes, satellites, and instruments designed to detect unusual objects, atmospheric phenomena, or interstellar visitors. If Oumuamua was a messenger, Loeb believes we must be ready for the next one. His ideas extended to 3 Atlas when it appeared in 2025. While Borisov behaved like a normal comet, 3I Atlas once again showed anomalies, particularly its bizarre chemistry, with carbon dioxide outnumbering water by a factor of 8-1. Loeb seized on this, noting that 2 of the 3 interstellar objects we have seen so far refuse to fit neatly into natural categories. Why assume coincidence? Why not entertain the idea that these are part of a broader pattern, evidence of technologies, relics, or probes drifting through the galaxy? Critics remain cautious, often dismissive. They point out that no direct evidence supports the artificial interpretation, no signals, no signs of metal or machinery, no deliberate maneuvers. To them, suggesting alien technology without conclusive proof risks undermining scientific credibility. But Loeb counters that ignoring anomalies is a greater danger. If we are too afraid to consider extraordinary explanations, we may miss extraordinary discoveries. Loeb also highlights the historical lesson. In the past, humanity has often misjudged natural phenomena because we lacked context. Meteors were once thought to be supernatural. Lightning was a mystery before electricity was understood. Comets were feared as omens until their orbits were charted. If we dismiss interstellar objects as mere rocks without exploring the possibility of something more, we may be repeating the same mistake. To Loeb, humility is key. We must accept that we do not yet know what these objects are, and we must remain open to all possibilities. For the public, Loeb's theories are electrifying. They speak to a deep human longing, that we are not alone, that the galaxy is alive with intelligence. The idea that alien technologies might already have passed through our skies is far more thrilling than waiting for a radio signal that may never come. And unlike science fiction, this is grounded in real data, real objects, real anomalies, real mysteries. The controversy around Loeb reveals a divide not just in astronomy, but in the philosophy of science itself. Should science be cautious, sticking to the most conservative explanations until proof forces us otherwise? Or should it be bold, entertaining hypotheses that seem unlikely but fit the evidence better than strained alternatives? Loeb insists on boldness. He argues that playing it safe may prevent us from recognizing the most important discovery in human history. The story of Avi Loeb's theories is not just about one man or one object. It is about how humanity confronts the unknown. Do we retreat into skepticism, or do we open our minds to possibilities that challenge our assumptions? When the next interstellar visitor arrives, and astronomers believe many more are coming, Loeb's ideas will once again shape the debate. Whether or not he is correct, he has ensured that we will look more carefully, question more deeply, and remain alert to the possibility that the universe is far stranger than we imagine. Would you like me to continue with why many scientists resist the alien explanation in the same 1,200-word style? Science can't fully explain their unique properties yet. When astronomers spotted Oumuamua in 2017, it was the first time humanity had ever observed an interstellar object passing through the solar system. Immediately, it broke the mold. Its shape was elongated or perhaps flattened like a pancake. It reflected light strangely. It lacked a cometary tail, yet it accelerated as it left the sun, as though some unseen force was pushing it. Scientists scrambled to explain these oddities, offering models of hydrogen icebergs, nitrogen shards, or dust fractals, but each hypothesis carried problems, leaving the mystery unresolved. Then, only 2 years later, Borisov appeared, behaving much like a traditional comet with water vapor and cyanide gases. Relief rippled through the community. Here was a visitor that made sense. But in 2025, when 3I Atlas arrived, the puzzle deepened again. Its trajectory was hyperbolic, as expected of an interstellar traveler. Yet, it deviated slightly in ways not easily explained by gravitational models alone. More striking still was its chemistry. a carbon dioxide to water ratio of 8 to 1. In our solar system, water dominates cometary compositions, with CO2 as a minor player. 3I Atlas was inverted as if it had formed in an alien nursery where water was scarce or absent. For astronomers, this was a revelation. For theorists, it was also a problem. How do you reconcile these numbers with existing models of planetary formation? The truth is that science, at least so far, cannot fully explain the unique properties of these interstellar visitors. Oumuamua's acceleration remains an open question. No model of outgassing, radiation pressure, or fragmentation has satisfied all the data. Every explanation requires assumptions that strain credibility. 3I Atlas's chemistry is equally perplexing. Laboratory simulations and cosmic ray processing experiments may eventually reveal pathways that produce such imbalances, but for now, no definitive explanation exists. Even Borisov, while seemingly normal, carried unusually high levels of certain volatiles compared to most solar system comets, raising subtle questions of its own. This uncertainty is not a failure of science, it is its very essence. Science advances by confronting anomalies, by wrestling with data that don't fit. In the 17th century, the orbit of Mercury defied Newtonian mechanics until Einstein's theory of general relativity explained it centuries later. In the 20th century, the radiation of black-body curves puzzled physicists until quantum mechanics redefined our understanding of energy. Today, interstellar objects may represent the next such frontier, phenomena that challenge existing frameworks, demanding new theories, perhaps even new paradigms. Some scientists argue that the oddities may simply reflect our limited sample size. 3 objects are not enough to define a population. Perhaps interstellar debris is more varied than we imagined. Perhaps 3I Atlas is not unusual in its own birthplace, but typical of comets formed in carbon-rich environments. If so, then the fault lies not in our theories, but in our assumptions that other planetary systems must resemble our own. If 90% of our observed comets are water-rich, it does not mean the galaxy shares that bias. The universe may be stranger, broader, more chemically diverse than we think, yet others caution against assuming natural explanations will eventually resolve everything. They point out that anomalies sometimes point toward entirely new phenomena. Oumuamua's acceleration, for instance, could be the first observational hint of physical processes we don't yet understand. Subtle interactions between interstellar ices and radiation, or even exotic material properties we have never encountered. 3I Atlas's chemistry could reveal that planetary formation is governed by factors beyond temperature and distance from a star, perhaps by the distribution of elements seeded by ancient supernovae. These questions cut to the heart of cosmochemistry, reshaping our view of how systems across the galaxy are built. The most provocative possibility, of course, is the one Avi Loeb and others have raised, that some of these anomalies may point to artificial origins. While many scientists resist the alien probe hypothesis, they also admit that current science does not close the case. No natural model explains every detail of Oumuamua. No planetary formation theory accounts neatly for 3 Atlas's CO2 dominance. To dismiss these as solved mysteries would be premature. At minimum, they remain open puzzles, and open puzzles are where breakthroughs often emerge. This ambiguity also highlights the limits of our observational tools. Both Oumuamua and 3 Atlas were discovered late in their journeys, already speeding away from Earth. By the time instruments were trained on them, the window for detailed study was narrow. No spacecraft was close enough to intercept them. No probes were launched to fly alongside them. Our understanding rests on spectral data, brightness measurements, and orbital calculations. All powerful, but incomplete. With so little to go on, even the best theories remain speculative. The anomalies may persist simply because we lack sufficient data to resolve them. That recognition has inspired a new movement within astronomy, preparing for the next one. Missions like the Vera C. Rubin Observatory, set to begin full operations this decade, will survey the skies with unprecedented sensitivity. It is expected to detect dozens, perhaps hundreds, of interstellar objects in the coming years. With earlier detection, scientists hope to study them more thoroughly, and perhaps even send spacecraft to intercept one in real time. If anomalies persist across a larger sample, the case for something truly extraordinary will grow stronger. If not, they may fade into the background of natural diversity. Either way, we will learn. For now, however, we are left in a liminal state. The data are too strange to dismiss, but too limited to conclude. Science cannot yet explain why Oumuamua accelerated, why 3I Atlas carries such exotic chemistry, or why these first interstellar visitors refuse to fit into familiar categories. And in that uncertainty lies both frustration and excitement. Frustration, because scientists crave resolution. Excitement, because mysteries are the seeds of discovery. Public fascination thrives in these gaps. Headlines about alien probes or exotic chemistry capture the imagination because they echo humanity's oldest questions. Are we alone? How unique is our world? Could visitors from other stars have already brushed past us, unnoticed except for their odd signatures? While scientists tread cautiously, the public is free to speculate, and in that speculation, a bridge forms between myth, imagination, and science. What remains clear is that interstellar objects are not trivial curiosities. They are ambassadors from other systems, carrying with them the fingerprints of alien environments. Whether natural or artificial, ordinary or extraordinary, their unique properties demand explanation. Until science provides one, they remain mysteries, reminders that the universe is not yet fully mapped, that wonder still lurks in the skies. The story of Oumuamua, Borisov, and 3 Atlas is still being written. Future visitors will add chapters, perhaps resolving the anomalies, perhaps deepening them. But at this moment in history, the truth is simple. Science cannot yet explain their unique properties. And that truth, humbling though it is, may be the important discovery of all. It tells us that the cosmos still holds surprises, that we do not yet know everything, and that the greatest mysteries may pass right before our eyes, fleeting but unforgettable. Would you like me to continue this arc by writing a conclusion documentary segment tying together Oumuamua, Borisov, and 3 Atlas as a trilogy of unresolved interstellar enigmas? 1,200 words. Ancient legends of visitors, promising to return when the stars aligned across the ancient world, myths and sacred texts preserved a haunting promise that powerful beings from the stars would one day return when the heavens marked the proper time. These were not vague tales of distant gods who remained forever unseen. They were specific accounts of figures who had walked among humans, imparted knowledge, and departed with a promise that when the sky itself offered the right signs, an alignment of stars, the rising of a sacred constellation, or the blazing of a comet, they would come again. For the Mayans, this theme was encoded in the stories of Kukulkan, the feathered serpent. Known to the Aztecs as Quetzalcoatl, this deity was more than a mythic figure. He was a teacher who brought agriculture, science, and order. After completing his mission, he departed across the sea or ascended to the sky. Yet the priests told the people he would return when Venus, his sacred star, reached a particular alignment. The Mayans tracked the cycles of Venus with astonishing precision, constructing observatories and codices to record its path. Every reappearance of Venus as the morning star was loaded with meaning, but they looked for a special alignment, a cosmic sign that Kukulkan's promise might soon be fulfilled. In Mesopotamia, the Sumerians told of the Anunnaki, whose very name means those who came down from the heavens. These beings were depicted not as distant, abstract gods, but as figures who arrived from the skies and taught civilization itself. The cuneiform tablets describe them as rulers, judges, and bringers of wisdom, but they did not remain. Instead, they returned to the heavens, with inscriptions hinting that they would come again when the heavenly tablets aligned. Babylonian astrologers inherited this expectation, watching the heavens for omens. To them, the sudden appearance of a comet, or fiery star, was not a meaningless accident. It was a sign that the cosmic calendar had moved closer to fulfillment. The Egyptians preserved their own return legends in the cults of Osiris and Isis. Osiris was linked to Orion, Isis to Sirius. These weren't just symbolic associations. The Egyptians believed the stars were gateways and that their gods could travel through them. When Sirius disappeared from the sky for 70 days and then rose again just before dawn, it was read as Isis's rebirth, her return to bless the flooding of the Nile. The pyramids themselves were built in alignment with Orion's belt, architectural declarations that the cycle of the stars marked divine promises. Texts from the Pyramid Age speak of pharaohs ascending to the stars, not only to dwell with the gods, but to prepare for their return alongside them when the constellations realigned in their ancient patterns. In India, Hindu cosmology was steeped in cycles of return. Time was not linear, but circular, unfolding in vast epochs called yugas. Within each cycle, the god Vishnu was said to descend in avatars whenever the balance of Dharma, the cosmic order, was threatened. Krishna, Rama, and others were understood as such manifestations. But the scriptures also made clear that these avatars would not be the last. At the end of the current age, when the stars and planets returned to their destined alignment, Vishnu would descend once again as Kalki, riding a white horse, to reset the world. This cycle of divine returns was embedded in the stars, the planets, and the eternal turning of cosmic time. Even the Greeks and Romans, though more focused on anthropomorphic gods, embraced the idea of divine return. The myth of Romulus, Rome's legendary founder, told of his mysterious disappearance into a storm cloud during an assembly. His followers later claimed he had ascended to the heavens, promising to return in Rome's hour of need. Comets, eclipses, and alignments of planets were interpreted as signs of his continued guardianship. Roman emperors, keen to link themselves with divine cycles, often declared comets at their coronations or deaths as symbols of their godlike destiny. The return of divine favor was always tied to celestial markers. Farther north, the Norse myths preserved the prophecy of Ragnarok, the end of the age. The gods, led by Odin, were fated to perish in a cosmic battle, only to return in a renewed world. The timing of these events was bound to the heavens, wolves swallowing the sun and moon, stars falling from the sky, the alignment of cosmic forces. To the Norse imagination, the heavens did not simply light the world. They measured it, controlled it, and dictated the return of gods in fire and glory. What unites these disparate traditions is not merely the idea of return, but the insistence that the timing would be written in the stars. The heavens were seen as a cosmic calendar, a system of cycles that linked divine action to celestial events. A sudden comet was not just a frozen ball of ice, it was a messenger, the harbinger of return. A rare planetary alignment was not chance. It was the signal that the gods' promises were about to be fulfilled. This theme resonated with ordinary people because it gave order and hope. Life was often uncertain, filled with famine, war, and suffering. The idea that gods had once come and would come again when the heavens aligned offered reassurance. It meant history was not random. It was cyclical, destined to turn toward renewal. Every blazing star overhead, every comet trailing fire, could be read as a reminder that the ancient promises still stood. Modern astronomy strips away the myth, but retains the awe. Today, when an interstellar visitor like 3I Atlas blazes across the sky, we describe its hyperbolic orbit, its alien chemistry, its fleeting passage. Yet one cannot help but hear the echo of the old stories. To an Egyptian priest, 3I Atlas would have been Isis returning in her fiery chariot. To a Mayan astronomer, it would have been Kukulkan's sign in the sky. To a Babylonian scribe, it would have been the Anunnaki announcing their approach. What makes this theme so enduring is that it taps into a human truth. The sky is a mirror. We project our fears, hopes, and longings onto it. When the heavens deliver something rare and inexplicable, a comet with alien chemistry, a star that appears and vanishes, we interpret it as a promise fulfilled. The ancients wrapped these interpretations in myth. We wrap them in science, but the emotional core is the same. A recognition that we are part of a larger story, written in the stars, unfolding in cycles of departure and return. In a way, the ancients were not entirely wrong. The universe does deliver returns, not gods perhaps, but visitors nonetheless. Oumuamua in 2017, Borisov in 2019, 3 Atlas in 2025. Each appeared suddenly, briefly, and departed forever, just as the legend said the heavenly visitors would. Each was a reminder that the heavens are alive with motion, that our solar system is not isolated, and that the story of the stars includes travelers who pass through, vanish, and may come again when the cosmic cycles align. Would you like me to continue with, could comets like 3 Atlas be connected to those promises? In the same 1,200-word narrative style? Could comets like 3I Atlas be connected to those promises? When the faint streak of 3I Atlas appeared in early 2025, astronomers knew immediately that they were witnessing something extraordinary. It was only the third confirmed interstellar object ever observed, and like its predecessors, it defied easy explanation. Its chemistry was unlike any comet in our solar system. Its orbit was hyperbolic, ensuring it would never return. To modern science, these qualities are puzzles to be solved. But to ancient eyes, the sudden appearance of such a body would have been unmistakable, a fulfillment of promises etched into legend that when the stars aligned, the visitors would return. Could comets like 3I Atlas be connected, even symbolically, to those promises? To explore that question, one must first understand how deeply comets were woven into the myths of return. The Mayans, who charted the movements of Venus and comets with obsessive care, believed the feathered serpent god Kukulkan would one day reappear, heralded by celestial signs. When a new comet blazed across their sky, it was not dismissed as mere ice and dust. It was read as the signal of renewal. Similarly, the Aztecs tied the smoking stars, their term for comets, to Quetzalcoatl's eventual return. To them, the heavens themselves were the canvas on which prophecy was painted. In Mesopotamia, Babylonian astrologers saw comets as harbingers of change. The return of the Anunnaki was expected when the tablets of the heavens aligned in certain ways. A fiery visitor cutting across the predictable stars fit perfectly into that role. The Egyptians, too, linked comets and stellar risings with divine cycles. The appearance of Sirius each year brought the life-giving flood of the Nile, reinforcing Isis's promise to watch over the land. A stranger star, like 3I Atlas, would have been interpreted as the return of Osiris or another god, manifesting in light and motion. From this perspective, comets were not anomalies. They were appointments. They arrived suddenly, brilliantly, and then disappeared forever, echoing the mythic pattern of visitors who descended, imparted knowledge, and promised to return. 3I Atlas fits this archetype almost perfectly. It entered from beyond the known, glowed faintly as the sun warmed it, revealed an alien chemistry unlike anything local, and then departed into the dark, never to be seen again. For scientists, this is orbital mechanics. For mythmakers, it is divine fulfillment. But could there be a deeper connection? Could ancient peoples have witnessed interstellar visitors like 3 Atlas before and enshrined them in their myths? After all, humanity has been watching the skies for tens of thousands of years. If modern telescopes can detect 3 such visitors within a decade, it stands to reason that many more must have passed unnoticed in earlier times. To the naked eye, they would have appeared as rare, blazing comets, too fleeting to catalog, but unforgettable enough to inspire story. Legends of gods promising to return when the stars aligned may therefore be rooted not only in imagination, but in real, observed phenomena. Consider the Mayan emphasis on cycles. They recorded Venus's movements with astonishing precision, linking them to wars, sacrifices, and prophecies. But Venus was not the only unpredictable visitor they observed. Comets, with their sudden fiery brilliance, were even more dramatic. If a rare interstellar comet had passed through their skies centuries ago, it might have been immortalized as Kukulkan's descent, or his promise of return. The same could be true for Mesopotamia. The sudden arrival of a fiery stranger would have confirmed the Anunnaki's pledge to come again when the heavens signaled it. Skeptics argue that myths of return are purely symbolic, reflecting cycles of nature, floods, harvests, seasons, rather than actual celestial events. Yet the specificity with which many traditions tie returns to stars, comets, and alignments suggests otherwise. These were not vague metaphors. They were calendars written in the heavens, pointing to real phenomena. The alignment of Orion's belt with the pyramids, the tracking of Sirius in Egyptian temples, the Mayan codices of Venus, all show an obsession with celestial timing. Visitors were not expected to return at random, but when the heavens delivered the proper sign. In that context, 3I Atlas resonates with uncanny force. Its exotic chemistry, a carbon dioxide to water ratio of 8:1, is so alien that it might as well be a cosmic fingerprint, a signature from another system. Ancient peoples would not have measured such ratios, of course, but they would have seen the strangeness with their own eyes. Perhaps a comet that glowed differently or vented gases in unusual colors. Such distinctions would only deepen the belief that it was not an ordinary star, but a messenger. There is also the theme of messengers in myth. Many cultures did not describe gods themselves blazing across the sky, but rather their heralds. They're signs, they're markers. In Hindu tradition, the avatars of Vishnu descended at the turning of ages, but their approach was often signaled by omens in the heavens. In Greco-Roman lore, comets were interpreted as heralds of divine intervention, marking the death of leaders or the rise of new ones. Julius Caesar's death, for instance, was followed by the appearance of a great comet, which Romans took as proof of his deification. In this way, comets like 3i Atlas could easily have been seen as the messengers of return, fulfilling the promises embedded in myth. Modern astronomy gives these legends new resonance. When we detect 3i Atlas and measure its alien chemistry, we are decoding a message, not from gods, but from the galaxy itself. Each interstellar object is a messenger from another system, carrying the chemical story of its birthplace. In a sense, the myths were right. The heavens do send messengers, and they do carry knowledge, even if the form is scientific rather than divine. The promise of return is fulfilled not by gods descending, but by interstellar visitors blazing across our skies at intervals we cannot predict. Could ancient peoples have anticipated this? Perhaps not in detail, but they recognize the pattern. Strangers come from the heavens, stay briefly, and depart, only to be replaced eventually by others. They framed this cycle as the promise of gods. We frame it as the passage of interstellar debris. But the continuity is striking. Both perspectives affirm that we are part of a larger cosmic story, one in which visitors return not once, but again and again whenever the cycles of the galaxy bring them our way. In this light, 3i Atlas is not only an astronomical discovery, it is a cultural bridge. It shows us that the ancients, in their own way, were observers of the same phenomenon. They wove stories of return into myth. We weave them into science. And while the languages differ, the awe is the same. Both recognize that when a blazing stranger appears in the sky, it is no ordinary event. It is a reminder that the cosmos is alive, that visitors do come, and that their arrival is always, in some sense, a return. Would you like me to continue with theories of markers or messengers traveling across galaxies in the same 1,200-word documentary style? Theories of markers or messengers traveling across galaxies. For thousands of years, comets and blazing stars were interpreted as signs, celestial messengers carrying divine meaning. Modern astronomy has replaced myth with measurement, yet the language of messengers still lingers. Interstellar objects like Oumuamua, Borisov, and 3 Atlas are not just random rocks wandering the void. They are fragments of alien systems, carrying within their chemistry and motion the fingerprints of their birthplaces. They are, quite literally, messengers, natural bodies that cross interstellar distances to deliver information to us. But beyond the scientific view, some thinkers have speculated further. Could these objects be intentional markers placed or launched by advanced civilizations as a way of leaving messages across the galaxy? The idea of cosmic messengers has both scientific and speculative roots. On the scientific side, interstellar objects are inevitable. During the birth of planetary systems, countless comets, asteroids, and icy planetesimals are ejected into space by the gravitational pull of giant planets. These fragments then drift across the galaxy, potentially surviving for billions of years before passing through another system. Every one of them is a time capsule. Their chemical composition records the conditions of their home star's nursery. When we analyze an object like 3i Atlas and find an 8:1 carbon dioxide to water ratio, we are reading a message, not one written intentionally, but one inscribed by physics and chemistry. It tells us that planetary systems can form under very different conditions from our own. In this sense, all interstellar objects are messengers, whether or not anyone sent them. Yet the theory of intentional markers pushes the idea further. Some researchers and philosophers of science have asked, if humanity, a young technological civilization, already dreams of sending probes to other stars, what might older civilizations have done? Instead of trying to broadcast fragile radio signals across light years, they could have seeded the galaxy with durable messengers. Artifacts disguised as natural comets, carrying information for any civilization advanced enough to study them. These markers would not need to be maintained. They could drift endlessly, waiting to be intercepted. The alien probe hypothesis advanced by Avi Loeb about Oumuamua taps directly into this line of thought. A thin light sail drifting across the galaxy could act as both a messenger and a marker, It might not be active or transmitting, but its very existence would reveal that someone had once engineered it. Similarly, an object like 3I Atlas, with its strange chemistry, inspires speculation. Could such anomalies be deliberate signatures designed to stand out from natural bodies? An engineered comet might not look like a spacecraft in the traditional sense. Instead, it could be a kind of cosmic graffiti, a chemical or orbital pattern so unusual that any intelligent species would recognize it as artificial. Science fiction has long played with these possibilities. Arthur C. Clarke's Rendezvous with Rama imagined an enormous cylindrical spacecraft passing through the solar system, initially mistaken for a comet. More recently, thinkers have suggested lurkers, hidden probes parked in stable orbits around Earth or the Moon, designed to observe silently. But interstellar messengers take the concept further. They would not lurk near one world, but wander between many, carrying a signal of presence. Their trajectory itself would be the message. We were here, we crossed the stars. One theory imagines these markers as part of a galactic communication network. Instead of relying on radio or laser transmissions that weaken with distance, civilizations could distribute physical messengers, small probes or disguised comet-like objects that slowly migrate across star systems. Each one could carry vast amounts of information etched into durable materials. Over time, a civilization could seed the galaxy with these messengers, ensuring that even after they were gone, their knowledge endured. Humanity has already considered doing something similar. The Voyager probes, launched in the 1970s, carry golden records etched with sounds and images of Earth. They are, in effect, messengers, our attempt to leave markers for whoever may find them. The question then arises, could objects like 3I Atlas or Oumuamua actually be part of such a system? Critics point out that there is no evidence of technology in these bodies, no radio signals, no metallic surfaces, no regular geometry. They behave, at least outwardly, like natural objects. Yet proponents of the marker theory suggest that if such messengers were designed to last across eons, they might be built to resemble natural debris. Camouflage would protect them, and the message might not be obvious. It might be encoded in subtle anomalies, unexpected chemistry, unusual motion, or behavior that defies ordinary explanation. Even if we set aside the possibility of engineering, the concept of natural messengers still carries weight. Every interstellar comet that passes through our solar system is a data packet from another star. It is a fragment of geology we cannot otherwise sample. Each one expands our understanding of the diversity of planetary systems. In this sense, the galaxy is already seeded with messengers, scattered by gravity rather than intent, but no less meaningful. They remind us that we are connected to the wider cosmos, that our solar system is not an island, but a crossroads. For ancient peoples, comets were messengers of the gods. Their sudden brilliance was read as a sign of divine will, sometimes joyous, often fearful. Today, science replaces gods with galaxies, yet the messenger role remains. Oumuamua told us that interstellar visitors exist. Borisov told us that some are comet-like. 3 Atlas told us that alien chemistry can be radically different. Each has carried a message that reshapes our view of the universe. The implications are profound. If interstellar objects are purely natural messengers, then studying them is our best way to understand the diversity of planetary systems. They are samples delivered to our doorstep, free of charge, carrying with them the secrets of distant suns. If some of them are artificial markers, the implications are even greater. It would mean we are not alone, that other intelligences have walked the galaxy before us, leaving behind breadcrumbs for us to find. In either case, the message is the same. The universe is alive with travelers, and we are part of a larger conversation written in trajectories and spectra. For now, 3I Atlas has departed, its faint glow fading as it slips back into interstellar darkness. But its role as a messenger remains. Scientists will pore over its data for years to come, debating what its chemistry means, what its orbit implies, and what its presence tells us about the galaxy. Mythmakers of old would have called it a herald of return, a fiery chariot bearing news from the gods. We call it an interstellar object, a messenger from afar. But across the ages, the meaning is the same. Something has come to us from beyond, carrying a message we are only beginning to decipher. Would you like me to now create a concluding documentary script that ties together the return theme, ancient myths, and modern discoveries like Three Eye Atlas into one final 1,200-word reflection? Three Eye Atlas will never return. Once it leaves, it's gone forever. When the interstellar object Three Eye Atlas was first detected streaking through the night sky in early 2025, astronomers knew immediately that it was different. Its orbit was hyperbolic, not elliptical. That meant it wasn't bound to the sun like planets, comets, or asteroids. It had come from outside the solar system, and once it swung around our star, it would vanish into the dark forever. Unlike Halley's Comet, which returns every 76 years, or the countless comets that cycle endlessly through the inner system, Three Eye Atlas will never come back. Its fleeting visit was its only performance on the human stage. This fact alone changes how we must think about it. Everything we wanted to know about Three Eye Atlas had to be discovered in the short window it was visible. There was no second chance, no promise of future observation. Astronomers scrambled, telescopes across the world turned toward it, and every instrument that could capture its light did so. Yet even with this flurry of study, so much remains uncertain. Its chemistry shocked researchers with an unprecedented 8-to-1 ratio of carbon dioxide to water, something unseen in our solar system. Its motion hinted at forces beyond gravity, echoing the mystery of Oumuamua in 2017. And now, like that earlier visitor, it has faded into the void and beyond the reach of even our most powerful eyes. For scientists, this is both thrilling and frustrating. Thrilling because interstellar objects are proof that the galaxy is a dynamic, interconnected place. Fragments of alien systems really do pass through ours. Frustrating because each one departs before we can fully decode its secrets. Three Eye Atlas was here and then it was gone. What it carried, its chemical signature, its history, its meaning can only be pieced together from the incomplete data gathered in its brief visit. It leaves a reminder: the universe doesn't wait for us. Its wonders pass whether or not we're ready. But this fleeting passage also carries a deeper weight. In myth and legend, visitors from the heavens often appeared suddenly, brought messages, and then departed forever. They didn't stay. They didn't linger. They arrived as omens or as messengers, and their absence was part of the mystery. Three Eye Atlas fits this pattern with uncanny precision. To the ancients, such a blazing alien star would have been no accident. It would have been a sign, an arrival foretold, a return promised, or perhaps even a warning. That warning is easy to overlook in our scientific age, but it still resonates. Three Eye Atlas will never return, and that makes its single appearance feel more deliberate, more meaningful. It is not a member of the solar system family, circling endlessly. It is an outsider, a wanderer, a traveler from somewhere beyond. Its very path declares that it does not belong here and that its presence is temporary. To see such an object is to glimpse the broader galaxy itself, vast, cold, filled with fragments that cross unimaginable distances. Its passage reminds us of how small we are and how brief our opportunities to study the unknown can be. And yet, the fact that it will never return also gives it a sense of mythic finality. For the ancient Egyptians, the reappearance of Sirius each year was proof of divine cycles, the promise of return. For the Mayans, the cycles of Venus measured the timing of Kukulkan's prophecies. But for Three Eye Atlas, there is no cycle, no return, no promise of repetition. It came once and now it is gone. That fleeting uniqueness places it closer to the gods of Sumerian legend or the fiery omens of Norse prophecy, visitors who appear only at the turning of ages, never to repeat their arrival. To us, the mystery is not only scientific, but existential. What does it mean that the galaxy sends us these visitors, only to whisk them away again? Are they merely debris, the flotsam of creation? Or are they, as some speculate, deliberate markers, messengers seated across space to remind us that other worlds exist? Science tells us the former, yet cannot fully explain their peculiarities. Myth leans toward the latter, insisting that their rarity is what makes them meaningful. Between those perspectives lies the truth we cannot yet grasp. Three Eye Atlas came, it astonished us, and it will never come again. Its departure is both closure and invitation. Closure, because the object is gone, our chance to study it fading with every passing day. Invitation, because it forces us to prepare for the next one. We now know interstellar visitors are not once-in-a-lifetime events. They are part of the galaxy's rhythm. If 3 have appeared in less than a decade, there will be more, and each one, like 3I Atlas, will carry mysteries we cannot anticipate. The challenge is to be ready, to have the instruments, the missions, the imagination to grasp them before they vanish forever. But in this moment, as 3 Atlas slips away, we are left with the haunting reality of its uniqueness. Once it leaves, it's gone forever. That fact alone transforms it from mere comet to cosmic parable. It tells us that the universe is filled with wonders that will brush past us only once. Some mysteries are not meant to be solved, only witnessed. And in witnessing them, we are reminded that our place in the cosmos is not fixed, but fleeting, like the visitors themselves who come, blaze briefly, and then vanish into the dark. Would you like me to continue with "But its fleeting passage leaves more questions than answers" in the same 1,100 to 1,200 word documentary style? But its fleeting passage leaves more questions than answers. The story of 3 Atlas is not one of answers neatly delivered, but of questions multiplied. From the moment astronomers realized it was interstellar, only the third such visitor ever confirmed its presence carried weight. It was a messenger from beyond the solar system, a shard of some alien nursery flung into the void. And yet, despite the flurry of observation campaigns, despite every telescope turned toward it in those few precious weeks, what it left behind was not clarity, but confusion. Its fleeting passage leaves us with more questions than answers. The first and most obvious question is, where did it come from? Tracing the origin of an interstellar object is nearly impossible. Stars move, galaxies swirl, and over millions of years, the trail grows cold. By the time 3 Atlas reached our skies, its home system could be halfway across the galaxy from where it began. Simulations can project possible paths, but no definitive parent star emerges. Was it born around a red dwarf, where cooler temperatures allowed carbon dioxide to dominate? Or did it form in the outer reaches of a larger system, ejected by a gravitational dance with giant planets? We may never know. Its birthplace is lost in the vast churn of the Milky Way. Then comes the question of its chemistry. The discovery that 3I Atlas contained 8 times more carbon dioxide than water shattered expectations. No comet in our solar system carries such a ratio. What process could produce it? Some astronomers suggest it was born in a water-poor environment, perhaps where oxygen was scarce. Others argue cosmic rays over millions of years could have destroyed water ice, leaving carbon dioxide intact. But neither explanation fully satisfies. If cosmic rays stripped the water, why did they not also deplete the CO2? If it formed in a water-poor system, what does that say about the diversity of planetary nurseries across the galaxy? Instead of one answer, the chemistry opens a dozen new mysteries about how matter organizes itself on alien worlds. Another unresolved issue is its trajectory. Like all interstellar objects, it followed a hyperbolic orbit, ensuring it would never return. But subtle deviations hinted at possible non-gravitational forces, just as Oumuamua had displayed. Was this the result of outgassing, with jets of gas nudging it along? If so, why did we not see visible plumes or a proper tail? Could its unusual composition explain this, producing faint CO2-driven accelerations invisible to our instruments? Or was something else at work? Some property of its surface or structure we do not yet understand. The parallels to Oumuamua's strange acceleration only deepen the questions, suggesting that perhaps these visitors share more in common than chance alone should allow. The fleeting nature of the observation window compounds these mysteries. By the time astronomers realized 3I Atlas was interstellar, it was already receding from Earth. Unlike Borisov, which displayed a spectacular tail that could be studied in detail, Atlas remained faint, ambiguous. Every spectrograph reading, every brightness curve was a glimpse through fog. What we have is not a portrait, but a shadow, just enough detail to prove it is alien, not enough to decode its full story. How many secrets slipped away with it, carried into the dark where we cannot follow? These unanswered questions highlight another truth. We were unprepared. Humanity has no dedicated mission ready to intercept such objects. Spacecraft take years to design, build, and launch, yet interstellar visitors give us only weeks of warning. By the time one is discovered, it is already on its way out. This means each one leaves us with lingering regret ready. We could have flown alongside it, sampled its gases, measured its surface directly. Instead, we are left piecing together puzzles from afar. The questions multiply because we lack the tools to answer them. Yet perhaps the deepest questions are not scientific but philosophical. Why now? In the span of less than a decade, humanity has seen 3 interstellar objects, Oumuamua, Borisov, and 3 Atlas. For millennia, they passed unnoticed. Now, with our new eyes on the sky, we begin to see them. Are they rare, or are we only just now becoming aware of how common they are? If they are frequent, what does that say about the galaxy? Are we part of a cosmic highway of debris, constantly crossed by wanderers from other stars? And if so, could some of these wanderers carry more than ice and rock? Could they carry signatures of life, or even technology? These questions linger long after the comet itself has vanished. There is also the unsettling question of meaning. Ancient cultures would not have hesitated to answer it. To the Mayans, a comet was a sign of Kukulkan's return. To the Babylonians, it was the Anunnaki announcing themselves. To the Egyptians, it was Isis blazing across the sky. For us, meaning is more elusive. We call it debris. We calculate its orbit, we measure its spectrum. But deep down, we still wonder, why here? Why now? Does its alien chemistry tell us something about the diversity of worlds? Or is it just a random fragment except for the questions we attach to it? Each answer leads only to another mystery. If its chemistry is natural, it tells us planetary systems are more varied than we thought. But how varied? If its trajectory is purely gravitational, why do the models not fit perfectly? If anomalies are only artifacts of observation, why do they echo the strangeness of Oumuamua? The more we study, the less we know for certain. The object's fleeting passage mocks our hunger for certainty, offering only riddles in place of clarity. And perhaps that is the final question. Are we supposed to solve these mysteries at all? Some scientists argue that it doesn't matter whether we understand 3 Atlas fully. Its very existence is the message. It proves the galaxy is alive with travelers. It shows us we are not isolated. Each interstellar visitor, whether or not we decode its details, is proof that the stars share material with one another. They are bridges, reminders that the galaxy is a single system, not a collection of isolated islands. In that sense, 3i Atlas leaves us with questions because that is its purpose, to remind us that the universe is bigger, stranger, and more mysterious than we dare to imagine. Now it is gone. Its faint glow has slipped back into interstellar darkness, but its legacy endures, not as an answer but as a question. What else is out there? How many more visitors are on their way? What secrets will they carry? And will we be ready to meet them? 3i Atlas leaves us not with conclusions, but with curiosity, not with certainty, but with wonder. And perhaps that is the most important message of all. Would you like me to continue with Were the Ancients warning us about interstellar wanderers like this in the same 1,200-word style? Were the ancients warning us about interstellar wanderers like this? For the ancients, the heavens were not silent. The sudden blaze of a comet, the flicker of a new star, the rare alignment of planets, these were not random phenomena, but messages. Across cultures, comets were feared, revered, and remembered. They were called harbingers of kings' deaths, omens of wars, and signs of gods. But in the myths and legends of return, those stories of heavenly visitors promising to come back when the stars aligned, there lingers a haunting possibility. Were the ancients, in their language of prophecy and gods, warning us about real phenomena like 3i Atlas? Consider what such an object would have looked like to ancient eyes. A faint star grows brighter, trailing fire as it moves unpredictably across the sky. Unlike the fixed constellations, it appears without warning, blazing for weeks or months, then vanishing forever. To the Egyptian priests charting the heavens, or the Mayan astronomers keeping watch from stone observatories, this was no ordinary event. It was the breaking of the cosmic order, the arrival of a stranger from beyond. In that sense, their myths of returning gods and fiery chariots may not have been pure invention. They may have been cultural memory of such fleeting alien visitors. The Babylonians were masters of celestial recording. Their clay tablets catalog eclipses, planetary conjunctions, and unusual stars. Many such records explicitly link comets with warnings: famine, the fall of kings, or divine judgment. If interstellar wanderers occasionally passed through in ancient times, the Babylonians would have seen them. Without telescopes, they could not measure chemistry or orbits, but they would have recognized their difference, their suddenness, their brilliance, their refusal to follow familiar patterns. Their warnings may have been less about God's wrath and more about acknowledging the unpredictable, that the universe sends messengers who do not belong and who depart as quickly as they came. In Egypt, comets were woven into the fabric of myth. The star Sirius, which heralded the Nile's flooding, was revered as Isis's return. But stranger stars, comets with fiery tails, were feared as destructive omens. Texts describe fiery serpents in the sky appearing before calamities. Was this simply superstition or a genuine attempt to grapple with visitors like 3 Atlas, objects whose sudden arrivals disrupted the predictable cycles of the heavens? The myths of Osiris linked to Orion speak of death, rebirth, and eventual return. Could these narratives have encoded not just spiritual truths, but celestial ones, that wanderers from beyond do appear, and when they do, they change everything? The Mayan codices go further, suggesting a systematic link between celestial visitors and prophecy. Their astronomers tracked Venus, the sun, and the moon with extraordinary precision, but they also recorded comets. Known as smoking stars, comets were believed to herald great shifts in power. Kukulkan's promised return was not vague. It was tied to celestial events, to alignments and fiery appearances. It is not hard to imagine that an interstellar comet passing overhead, alien, brilliant, unique, would have been folded into this narrative, remembered as the fulfillment of prophecy, and later passed down as a warning to future generations. When such stars appear, change is at hand. In India, the Vedic and Puranic texts describe celestial omens with striking detail. Comets, or Dhumketu, literally smoke banners, were said to announce upheavals in the cosmic order. The Mahabharata describes fiery apparitions streaking across the sky before battles that reshaped the world. If civilizations in India witnessed interstellar comets, their appearance would have been immediately interpreted as signs of epochal change. Combined with the Hindu idea of cyclical time, the yugas, vast ages marked by decline and renewal, the sudden appearance of a unique celestial visitor could easily be seen as confirmation of cosmic prophecy. The texts do not describe hyperbolic orbits or alien chemistry, but they do insist that the heavens deliver warnings and that fiery wanderers are among the most significant. Even in Europe, comets were remembered as signs of divine intervention. Halley's Comet, visible in 1066, was said to have predicted the Norman conquest of England. Earlier, Roman historians recorded comets as heralds of emperors' deaths or ascensions. Julius Caesar's death was marked by a great comet, interpreted as his soul ascending to the heavens. These interpretations may have been political, but they also reflect a deep-seated belief. When a fiery star appears, history bends. The Romans did not know of interstellar objects, but they understood the psychological and cultural weight of such wanderers. Their myths of Romulus's promised return, heralded by storms and celestial signs, echo the same theme. Sudden visitors from the heavens mean transformation. Were these ancient warnings meant for us? Not in a literal predictive sense, but they preserved a worldview that resonates uncannily with what modern science is discovering. The ancients believed that sudden alien stars carried meaning. Today, we know they carry alien chemistry and trajectories that defy our expectations. The ancients warned that such appearances marked turning points. Today, scientists acknowledge that interstellar visitors redefine our understanding of the cosmos. The parallels are too strong to ignore. If we reframe ancient prophecy as observation, the warnings gain new relevance. The myths of return may not have referred to gods descending from the stars, but to the stars themselves descending into our skies as visitors. The cycles they spoke of may not have been supernatural calendars, but the unpredictable rhythms of interstellar wanderers. And the warnings they issued that such arrivals mark upheaval may have been less about divine punishment and more about existential humility. Reminders that we are not in control, that forces beyond our world occasionally intrude. For modern humanity, the resonance is profound. 3 Atlas, like Oumuamua before it, forces us to ask questions we cannot yet answer. Where did it come from? What does its alien chemistry mean? Could it carry the seeds of life or even the fingerprints of intelligence? These are the same kinds of questions the ancients asked, albeit in mythic form. Who sent it? Why now? What message does it carry? We're the ancients in encoding such questions into myth, warning us that these visitors are not accidents, but part of the larger story of the universe. In the end, whether or not the ancients foresaw interstellar wanderers like Three-Eye Atlas, their warnings endure as a reminder. The heavens matter. They are not silent. They deliver visitors that challenge our understanding, unsettle our certainties, and spark our imaginations. The ancients wrapped that truth in prophecy and legend. We wrap it in data and orbital mechanics. But both traditions converge on the same insight. When a fiery star blazes suddenly across the sky, it is not to be ignored. It is a warning, a message, a mystery. And so we are left to wonder. Perhaps Three-Eye Atlas is not just a comet, not just a fragment of another world. Perhaps it is part of the same cosmic rhythm the ancients tried to describe, a rhythm that binds us to the stars. Were they warning us? Perhaps not in the way they imagined, but in a sense, yes. Their myths prepared us for awe, for humility, for the recognition that the universe will send us visitors we cannot explain. And in that sense, their warnings still echo, thousands of years later, as Three-Eye Atlas slips back into the dark, carrying its unanswered questions with it. Would you like me to now write a final closing reflection that ties all of this together? Ancient myths, interstellar objects, and the enduring human need to find meaning in fleeting visitors from the stars into a single 1,200-word conclusion?